6,000, 6K live stream. Let's get it. We're gonna do some system design questions for once. I know I always wanted to get through these, but I mean, this time we'll actually focus more on system design. Let's see who pops into the channel. Thanks, man. Pop up the chat. Let's get straight into this. Design Dropbox. Let me tell the... Alright, let's get it. Design Dropbox, got Excalidraw. We got a bunch of the most popular questions. Let's just do a simple design Dropbox. Let me tell the channel I'm live. Design Dropbox. So practice this common problems system design. Start practicing. So design a file storage and synchronization service similar to Dropbox. Dropbox is a file hosting service that offers cloud storage, file synchronization, personal cloud, and client software. File synchronization, personal cloud. Okay. Users can upload files to remote storage. Makes sense. Users can download files from remote storage. Users can automatically sync files across devices. The scale is 100 million daily active users, and files can be up to 50 gigabytes in size. That's crazy. So this is the delivery framework, whatever. So what are the non-functional requirements? Okay, let's get into this. So non-functional requirements on Dropbox. Users can upload files to remote storage. I think availability over consistency. We need to make sure this is available so that users are able to always access their files. Fast uploads, fast downloads. So we should be able to upload fast and download fast, and then handle scale. It's going to be 100 million daily active users. Handle scale. There's going to be lots of storage. Yeah, we need to handle scale because there's going to be 100 million daily active users, so we're going to need to be able to store all this data. Ensure we can handle scale. What else? Fast uploads, fast down. We want durability. When it comes to data, and probably security comes to files. So it doesn't get leaked, and probably lastly being able to send data to synchronization, but I guess I don't know if we need to care about anything related to synchronization too much, or when it comes to speed. But yeah, so we're gonna prioritize availability over consistency. Dude, it's actually pretty good. I like it. How do you like it? So availability over consistency. We wanna. Alpha, thanks, bro. Does this include editing files as well, or just? I think just uploading and downloading. So I think let's just say, yeah. Alexander, are you part of the Discord? Yeah. Yo, can you add me on Discord? I'll DM you. I have like I know some other people who did some meta stuff, so I'll send you over some stuff. So essentially, we want availability over consistency. We want fast uploads and downloads to blob storage. We want durability when it comes to data, handle scale, and then security when it security of files. Whatever. Let's just get feedback on this right now. Damn, took an L right away. You're correctly identifying the importance of prioritizing availability over consistency. Okay, fault tolerance. Okay, yeah, that's true. Damn, I didn't think of that. So when they're uploading like a big file, and it fails, we need to allow them to start again. Okay. So let's just add that in. Fault tolerance. Users should be able to continue uploading. I don't have Instagram. Fault tolerance. Jalen. What's up? Wouldn't it be important for two users to see the same version of the file? That's important, but it's not that important for this case. Because, like, what's wrong with one user getting the file slightly later? This is Dropbox, not like Google Docs when they're collaborating in real time. In Google Docs, yeah, that makes sense. You want consistency. But when it comes to, this is more just file storage that you could sync across all of your different computers. So I think availability is more important here. Bro, Alpha, congrats, man. You got this. So fault tolerance, users should be able to continue uploading. If it fails, we should not lose data. This is the same thing because we can create multiple copies. So fast uploads to blob storage and let's say fast synchronization. Low latency. Alpha, you got this, bro. You're gonna kill it. Okay, yeah. I always forget to synchronize, or I always forget to actually quantify what I mean by low latency. So availability. So eventual consistency for file uploads is fine. Jalen, I hope that answers your question. Low latency upload as low as possible given file size, and low latency file sync. Okay. So why would availability be more important? Maybe the user can refresh the page and get their file later. Silent grinds. I just practicing. Jalen, so when it comes to the cap theorem, you want to let's look at some common examples, I guess. So pretend we have so these are very common system design questions, and let's just talk quickly about if we want to prioritize consistency over availability on them. For live comments, do we care about consistency or availability? What do y'all think? Like if we were to do Facebook live comments, like in this live stream, do we care that everyone is consistent? Realistically, 6K subscriber live stream. Yeah, but I need to. Yeah, Alpha, exactly. Availability. Why availability? Yeah, but explain. Lev, appreciate you, bro. Yeah, and Alpha, it's not really about ordering as well. It's more about like when we say consistency, we're also talking about consistency. Like all the clients should see the same exact data. Like order is one thing too, but yeah, I guess ordering is important as well. But basically, what we mean by consistency is by strong consistency is all clients are gonna see the exact same view of the data. So when it comes to like a banking application, that's very important that every single client sees the same exact version, because then you could lead to like either overpaying or underpaying someone, right? When it comes to something like Ticketmaster, right? It's important that everyone sees the exact same data because they need to know what tickets are available. You don't want two people booking the ticket and then all of a sudden they both have the ticket, or two people are able to get the same ticket, right? That's why consistency is very important there. Okay, what about Messenger? What do y'all think? Availability over consistency? Alexander, that's why you straight up just gotta do Python or something. Okay, what about Messenger? What are we doing? Availability or consistency? Alpha code. Yeah, but wouldn't it be weird if I send a message and then I reply to someone's message, then all of a sudden the message is a bit out of order? Pretend I say one thing. Like, I think with Messenger, it has to be consistent. I think consistency is important when it comes to Messenger. Because if we're getting messages out of order, it's going to lead to a weird user experience. So, thinking about it on the product side, you can see your. Yeah, that's true. That's true. You can see. Let's see. You can see messages right away, but not others. Yeah, I guess you're probably right here that we should probably let me think about it a bit. If we need to prioritize availability over consistency here, because yeah, everyone kind of. I think this one's close. I think this one's one where you could kind of debate two ways. You let's see what the hello interview says. Where's WhatsApp? Soulful, yeah, that's good. So, Alpha, you see here, I think this one's close, right? So this one, they don't even talk about the cap theorem at all. If we're gonna prioritize, but yeah, I see what you mean. I think I agree. I agree a bit what you're saying, but it looks like the view only mode. Yeah, yeah, yeah. I'll send this out. Okay. What about URL shortener? What do y'all think? Consistency over availability. Does it even matter there? Consistency over availability of our system. And then we'll get back into doing Dropbox. But yeah, honestly, some of them it doesn't matter as much. Yeah, and also one thing too is different parts of the system could have you could apply cap theorem to the different parts of your system, right? You can say that we need availability when it comes to redirecting URLs because that needs to be highly available. We don't want to have a URL You don't want to have a short URL that you can't convert to a long URL. You need high availability when it comes to redirecting. But when it comes to generating hashes, you can make that system strongly consistent so you don't get collisions on hashes. So that's like, two things can kind of be true. Or like different parts of your system you can make available while others you can make consistent. For example, Ticketmaster, right? You can make it available. You can pretty much make it available when it comes to like viewing the website and seeing all of the different concerts and events and stuff. But then when you click into the checkout flow, you can make the checkout flow specifically consistent or strongly consistent. So it's not like you have to apply blanketed approach of, oh, this whole system has to be available or consistent. You could like fine grain it to specific services in your system. Does that make sense? That's what the answer is. What are the core entities? Okay, let me look at the functional requirements. So when it comes to the core entities, we're gonna have probably files. Yeah, exactly. Yeah, exactly. You're right. I think you're right, Alpha. So we have files. I mean, we have the obvious users. I mean, do we want folders? So we want users, folders, and files. Maybe we want devices. Maybe we want to know people's devices. So I think with that, we have the different users. We can model all the different devices that user has, so we can sort of sync it across the different devices. And then on the cloud, we can make sure we just have regular folders and files. Yeah, Farzan, exactly. You can have some of your parts of system available. I think that's what Alpha's saying right there. Ben, yeah, got you, bro. Okay, let's see this. Yeah, it's a mock system design. Nice. So, oh, they have the file, the file data. Okay, the different clients. Yeah, okay. It's kind of what we have there. I didn't want to specify the file because file will probably have some, like a link to a URL or something like that, which would be it stored in S3. So what are the REST APIs that you'll expose to satisfy your functional requirements? Yeah, I'm just doing system design. I'll probably hop on the Discord chat at some point and just talk with people, but we're gonna do a few system design questions. And I'm also gonna go through the most common system design, These are probably 20 of the most common system design questions. And I listed out sort of the unique aspects of each of these questions. So things that you need to handle. So for example, with designing lead code, it'd be like ensuring security and isolation. With Ticketmaster, it'd be ensuring no two people buy the same ticket. For online auction, it's more about how do we ensure the highest bid is accurate for all users and strong consistency on the bids, stuff like that. I'm gonna fill the rest of this out later, but yeah. Then I'm gonna share it with y'all in the group chat, in the Discord. So API routes. Okay, what are we doing with API routes? Users can upload files to remote storage. So probably users can upload files to remote storage. So probably post, and then we can have files, right? You can post files, and then it'll probably return a file back. But this is going to be an endpoint to create a file, to upload file. Probably have some body, and in the body, I mean in the headers, we probably maintain the authentication. In the body, what we can do in the body is pass in the S3 URL. So file URL, and other metadata. So file name, string. What else? You can upload files. You can download files. Pretty much file name in the file URL. Yeah, I think that's all we need to care about here. And we could add more stuff if necessary after, but that will allow us to upload our files. We can also get files, and we can pass in a file ID, and that will return us a file. This doesn't return us the raw file. We'll probably get the link to S3, and then we could download it off S3. But essentially allows us to fetch a file from DB file, to fetch file metadata from S3 or from our DB. Yeah, that's what I'm doing. This is just we're gonna talk about that after, because. And Jalen, yeah, I've read that book. It's a pretty good book. It's hard to read. It took me like 3 months to read it, but yeah, I read it. Allows to fetch file metadata from our DB. I think everyone should read that book. Allows to fetch file metadata from our DB. Let's say response, and probably response would be something like a JSON. And we pretty much get probably our file ID back and probably file URL. Have 1 week to... Don't read that book if you have your interview coming up. That's more of a long-term knowledge thing. Just focus on like Alex Zhu's system design books. These ones. This one. Read this one. So we're getting files. Users can upload files to remote storage. Users can download files from remote storage. Okay. Probably probably something like file sync allows us to, or basically what we can do is we might have just we might just do a simple long pull, but syncs gets files from the maybe response is like a list of files, right? So periodically, this is a very naive solution, but my client, like my Dropbox client, might just be calling a GET request periodically to figure out what files it doesn't have, and then downloading it and syncing it, and it will do that as a background job. Because here we can either push or pull, either push files to the clients or they pull for it. So let's see if we hit all our functional requirements. Users can upload files to remote storage. Yeah, they can use this. Users can download files. Yeah, they can use this. Users can automatically sync files across devices. Then I'll just note one thing. Note. We will use pre-signed URLs to upload download from S3. Nice. Damn, I always forget to do pagination. So upload a file. Download a file. Yeah, it gets changes between local and remote. Okay, they have the same ones where they kind of sync it. And they also download files and post files. Yeah, they have the same 3 endpoints that we have. How will users be able to upload files? What we can do is, let's just talk about the data flow, for example. We have different clients. No, I think it's just getting a list of files that, okay, yeah. Mine's just getting new files, but you're right. It needs to get a list of files that changed. Yeah, you're right. So, yeah, it's just gonna periodically get the files and sync them. I think that's gonna be done client side. You're right. Thanks for calling that out. Yeah. Bro, this is why you landed that crazy TC, man. You're a GOAT. Gets files that aren't on this client. What are we doing? Get files that aren't on this client plus. Okay, let's talk about data flow. Let's talk about data flow, bro. How will users upload files? I don't get why it says this is not going to work with large files. Well, because, let me move back. Their solution is, they're not diving deep yet, but what they're saying is they're going to pass in the complete file into the post request. And usually that's like a big no-no, because you're going to be storing files in S3. It's better off to just straight download them to S3. So instead of, I mean, this is essentially what their solution is saying, right? So they have a client and they have a server, and then they have like some they have like some S3 storage, right? They're basically gonna send the data to the server, the binary data, and then the server is gonna upload it to S3, and then probably in our database it's gonna create an entry. Right? That's kind of what their approach is doing. And then it's going to say 200 or something. But there's a lot of issues with this approach. First, the server needs to be able to handle, like, it's going to put a lot of load on the server. And then on the server, you're going to have to implement things like retries. If pretend this connection breaks and it's halfway uploading a file, then on the server, you're going to need to support actually it connecting back and then resuming the upload. And plus there's extra latency here, right? You're sending over this big data to a server and then the server just forwarding it to S3. So instead, what the server should do is redirect you to S3 so you could upload straight to S3, because S3 handles all the things related to pretty much resuming downloads, resuming uploads, and is way more scalable than this single server. You don't have to implement any of that logic on the server. So that's kind of what they mean there. Yeah. So essentially, you should upload to S3 right away, or this should send you a pre-signed URL that you'll upload the file to, and yeah, it will essentially you make a request to the server. The server generates a pre-signed URL. creates a file object, stores that file object in the DB, returns it back to the client. Now the client has a pre-signed URL. It's just gonna download that file to the pre-signed URL. That's the flow there. So you don't want to actually pass the file in the post request. That makes sense, Jalen? Cool. Wait, let me... System design mocks. What are we doing? One sec, I'm just updating my description. Dude, it's pretty close. It's pretty close. It's pretty close. So how will users be able to upload files? So files will talk to, let's say we have, like for most of these, we'll just have like an API gateway. So let's just throw that in there. That will redirect traffic to our service. One second, let me just check on my stream real quick. Yo, they're pretty close though. Nice. So, we're pretty much going to have our clients. Then we're gonna have our our server, which this is gonna be. Let's call it our app server, application server. And what we're gonna do is we're gonna store stuff in S3, and then we're gonna have like a separate store for our database. And what we use for our database doesn't really matter here right now. So clients will talk to the API gateway, get routed to the app server. Like I mentioned, the app server is gonna create that file object and the pre-signed URL. That's gonna return all the way back. But essentially, clients will also be able to talk directly with S3 to upload and download files. Right? And then let's just say we're gonna have our file here. We're gonna start filling out this files. So we're gonna have file ID, we're gonna have file name, file URL, S3 URL, other metadata. So we're gonna have a file ID, a file name, a file URL, other data, and other things like created at, updated at. Those are like table stakes, stuff that you kind of throw on your tables to help you with debugging. And in this case, updated at will let us know when files are actually updated. So we have file ID, we have a file name, we have a file URL. Then we have other file metadata, maybe like the size and stuff. But let's just abstract that out for now. That's kind of like stuff we'll figure out as we go. So let's see how the AI likes this response. For this, Devam, like this case, it doesn't really matter what database you use. In a lot of these system design, honestly, you can make both of them work. You just need to understand how to make them work for your use case. So it's not like it's. I think most interviews you don't even need to discuss if you're going to use SQL or NoSQL. So how will users be able to upload files? So clients will pretty much send a post or... Sorry. Let me repeat this. Let me just look at my, okay. Yo, Google guy, thanks for being here. You're like my 100th subscriber, bro. Okay, how will users... So users will be able to upload files by sending a post request to our backend. Pretty much the post request will... let's see. Actually, no. They need to generate... We need... Hold up. Let me break this up. They're going to need to do a separate get request. Okay. I see. So I need to think about... I got you, man. Just wait till I'm up. So how will users be able to upload files? So clients will pretty much do a post request. Hold up. Yeah, you're right. Yeah, you're right. Good stuff, man. Good stuff. Okay. Let me... Oh, shoot. What the fuck? No way. Wait, let's refresh. Tweaked out. Okay. Okay, so users will send a post request to our service. The API gateway will route them to our app server or our app server our app server or whatever service we have for managing files. Wait, let me repeat that. That's a bad response. So pretty much the clients will make post requests to our backend and it's going to hit our app server. And pretty much what the app server is going to do is it's going to generate a row in our database for that specific file, right? And it's going to create a URL in S3 where the client is going to upload the file to. The post request that the client is sending is not gonna pass in the binary data because we don't want to relay that binary data to S3. Instead, we're gonna generate a pre-signed URL and we're gonna return that back to the client, and the client will upload directly to S3 using that pre-signed URL. Yeah, so pretty much that's how users will be able to upload files. When they do the post request, it's gonna be a very lightweight post request, and it's pretty much just some of the data we need in order to create the file object, and then we'll return back the S3 URL, pre-signed URL that they'll upload to directly. That's sort of the strategy for uploading files, and that reduces the load on our app server. And pretty much, yeah, they just send the binary data to and from S3. Nice. API gateway. The files will store the file in S3. Yeah, I think they're not optimizing theirs right away, but it's fine. Like when you only have so much time in the interview, I'll just optimize it right away. Dude, just read a bunch of articles. But honestly, like building or working in the industry is going to help you pick up these skills a lot faster. Like when I first studied system design as a new grad, it didn't make sense to me. But then when I worked in the industry for a few years and had to do some of this stuff and had to really think about these systems, it really, like, this became really easy for me after. Like this system design stuff, I could almost BS it every time. So how will users be able to download? Okay, let's just say right here. So users to download files from remote storage. So the same thing. We're not going to be routing downloads through the app server directly. As in, the app server is not going to be streaming the binary data back to the clients. Instead, what the client is going to do is they're going to do a GET request for a specific file. When it does the GET request, we're going to query our database to figure out that file. Their GET request is going to contain the file ID. On the client, we're going to list all of the different files that they have, so we'll have access to the file ID. But essentially, we're going to query the database for the file ID. That's a primary key, so it's a very efficient query. We're going to be able to extract out the S3 URL and other metadata and send that back to the client. Now the client can download directly from S3 because they have the URL, and it doesn't have to go through our app server, and our app server is just sending basic JSON data. Awesome guy, what's up? Light work. Oh, really? Okay, let me fix it. What about now? Wait. Yo, how's audio? Okay. How's audio? Better now? Bro, I hate when my audio sucks. If everything checks out, the file server generates a pre-signed URL for the file in S3. This URL is sent back to the client, allowing it to download the file directly from S3. This approach offloads the heavy lifting of file transfer to S3, reducing loads on our server. Once the download is complete, we might update some metadata like last access. This flow. Cool. Okay, now we're getting into some of the interesting parts. How will your system sync local file changes to remote? Let's see. We're gonna pretty much for all of these. The thing is, we're gonna have a client. We're gonna have a client app. So this is kind of like client side logic. How will the system? We're gonna have client side logic. I don't know. I think they have it upload too, or they'll probably fix that up later. Because you definitely don't want to upload, or you definitely want to upload directly to S3. Because what if it stops working halfway? Or S3 pretty much has a lot of the built-in things to allow you to continue download or uploads, allow you to continue downloads, and is way more scalable than what we have to implement our app server. If we had to implement that in our app server, we'll probably be duplicating a lot of the logic already in S3 and making it super hard for ourselves. So our app server should just be basic. So how will our system sync local file changes to remote S3? So I think what we're gonna do is I'm pretty sure on the client side, we need to have some client side logic. First, this is actually a harder question. How, we'll need some client side logic. Look out for file changes in the directories that Dropbox owns. I think we'll periodically send these files, and we'll probably, what we can even do is, Like I'm wondering if we periodically send these files to S3, and I'm wondering if we need to. I'm just wondering right now if we need to really replace the file. Do we replace the file in S3 or create another one with like a higher timestamp? I think we probably want some sort of versioning. So what we can do is we can add version here, and this is like we can have a version that's an integer, and pretty much as they make changes on their file, we could probably send like create new versions of the file and send it to S3, and then that way we could also see if changes are happening based on file versions. That's a very simple thing, or like a simple checksum or something. But I think we're gonna want to have different file versions, and that's gonna lead to a lot of extra data. But I think from the product perspective, it'll allow us to go to like be able to revert and stuff, or have a trail, or we don't lose people's data if something goes wrong. And we could have it so that we only keep like 3 or 4 copies of the latest versions or something. But yeah, we're gonna need some client side logic, and we could abstract that away. But the client side logic will look out for file changes in directories the Dropbox owns. This is gonna be Dropbox, and then periodically send these files to S3. And yeah, and then what do y'all think about that approach? Because yeah, as we make changes, we don't want to like stream that to S3. That doesn't even really make sense. We want to make changes, and as we make changes, but I guess we're only gonna be, yeah, as we make changes, we're gonna send those off to S3 periodically. It doesn't need to be really in real time, because Dropbox is usually for like one person, or it's not like a live collaborative editor. Farzan, what do you think? Yeah, that's what I mean. There's two approaches, right? We could either like upsert the file, or create another one with higher version. If we create another one, right? If we create another one, then we could have access to versioning. And honestly, S3 is probably smart enough to compact those files, right? Because yeah, we can just go ahead and upsert it to, do we replace the file or create another one with a higher version? But I think what we could just, as they make changes, like replace that file. I mean, those are the two options here, right? But I think the more you talk about it, maybe we'll just, maybe I'm overcomplicating it, and maybe we just need to replace the file. Okay. Okay, I see. So we just need to keep uploading the file to S3. Yeah, maybe we just need to keep uploading to the file. Yeah, I don't know. I'm kind of stumped on this one. Maybe we can probably just like post. Let's create a new endpoint called like put. We're gonna have let's just say we have a put, and then updates a file. So we pass in the file ID. So what it's gonna do is it's probably gonna give us a signed URL as well, and then we upload it to there again. And then like Sazam said, maybe it already handles the different versions. When we upload to a file, it will know that we overwritten that, and we let it handle versioning itself. So how will systems sync local files to remote storage? So we're gonna have some client-side logic, like a Dropbox app, they'll look out for file changes in the directories that Dropbox owns, or even just as we upload as like pretty much as we make changes, we'll know which files are changed because we're doing it on our client. But essentially, the gist of it is that there's client side logic that figures out when things change, and we could dive deeper into that later. But when things change, it'll periodically send these files to S3, and we don't need to just send it as they're making updates to it. We could send it periodically, and we'll have to introduce a new endpoint called put, where will essentially allow us to update a specific file. So when they call put for a file ID, I think it will return us another pre-signed URL to upload to that, pretty much to overwrite that object, and we'll just pretty much upload to that URL, and it should replace that object. But I think S3 also, there's I think you can set that, Farzan. But yeah, but also S3 will manage versioning for us. Let's go. Oh, nice. So Zam, thank you for talking about the S. So we're gonna leverage S3. So far, Zam, we do need some sort of versioning. So I added version there, but it's saying last sync that. So that will allow us to know when things have changed. Let's see. Okay. So the agent will then use our upload API to send change file to server, upload with updated metadata like modification time and file size. Our file service will upload these files. Yeah. We'll use last write wins approach for handling. This simple setup allows for basic local changes. Okay, yeah. So they're just handling the race conditions by last file wins and not doing anything too fancy to synchronize things. That's like a whole problem on its own. Let's look at their setup. Yeah, we have the API gateway. They have their own sync service, but whatever. How will your system sync remote file changes to local devices? I like what they did with introducing a file sync server. So we can have our regular app server that handles like CRUD operations. But then we could have something specific to like a file sync service. Right? So that way this can happen more, like we can scale these independently. How will systems sync file changes to local devices? I think just polling is fine. It all depends on how fast you need the client to receive the update. Do we care that the client sees it in real time? Probably not. So we don't need like an SSC, server side events, or we don't need WebSockets. We can we could probably just poll it periodically. Especially if I think we even only need to care when they're gonna even upload the file or they look into that folder. So let's talk about this. How will your system sync remote file changes to local devices? So all the different local devices are gonna have client side code running on them. So first off, when someone first opens up their computer and starts up the Dropbox client, that Dropbox client should make a call to our syncing service, our syncing endpoint, to sync its files with what's on the server. So that's gonna get clients who just spin up to get what's needed there, and then um, pretty much when a client is active, the most naive way is to just keep polling consistently, but we could also be smart of when we poll. Like if they're about to open up a file, we'll probably poll then and there. Maybe if they open up a folder, we'll poll the different files so that they get like an accurate view of their folder. But we can have the client side figure out when to poll for or when to sync with the server, and yeah, we can add logic so that we don't have all these clients spamming our apps or our file sync service when there is no updates. And yeah, there's two ways in general to solve these. It's either a push model or a pull model. We're gonna go with the pull model. A push model would be more, we have the clients and we're gonna push updates to them and they're not gonna ask for it. But I think for this case, when we don't need it to be real time, or that's not the biggest consideration, we can do a pull. You provided a comprehensive explanation of a pull-based model for syncing remote file changes to local devices. Your design considers initial sync when the client starts up and adjusts the need for efficient syncing to avoid overwhelming the server. I did introduce an extra syncing server. I'm too lazy to keep just drawing stuff. To sync remote, we'll have a client-side agent periodically pull our server for updates. Farzan, you're right. Let's say every few minutes, the agent sends a request. The sync service then checks the metadata for any files to see if it's been modified. And it sends, if there are changes, sends back a list of updated files along with their metadata. Yeah. Update with these. If a file has been deleted on the server, the agent will move it locally too. Yeah, cool. That's kind of what we said. Dude, we're going ham on this. What's everyone saying? How can your system handle uploading large files given limitations of most servers and clients on the size of the... So far as that, this is kind of something we already talked about. I'm gonna try to speed through this now so we can move on to a different question. But how are we gonna do this? Handle uploading large files. So in order to handle uploading large files, we're going to leverage S3. So clients aren't going to be uploading files directly to our app server. Instead, we're going to give them a pre-signed URL so they can upload and download specific or directly to S3. Allowing them to communicate with S3 is beneficial in this case because S3 handles a lot of is able to handle uploads of very large files and is fault tolerant, so that if you fail in the middle of uploading, it can let you continue uploading. And it's also designed for scale, and pretty much if we have to implement that in our app server, first it adds latency because we'll be streaming binary data to our app server, then to S3. And then secondly, we're going to have to deal with all of the good stuff that S3 has. Yeah, and my only even as files are getting uploaded over the network and like yeah, but far as that, oh sorry, far as that, and I think S3 should be able to handle that, right? It should have the protocol for sending large file data. And one thing we could do is chunk it up and stuff. Like we can have our own chunking and stuff. But yeah, that's one way. I guess I can mention that as well. Um, yeah, exactly. SGS multi-part or chunking. Yeah, exactly. Yo, we're killing it. Yo, Farzan, when do you start? Damn, why are you taking such a big break? Are you gonna travel or something? We'll use chunking upload with AWS S3 multi-part upload. The client initiates the upload with our file server for service, which creates a multi-part upload in S3 and upload ID. The client then splits the files into chunks, typically 5 to 10. For each chunk, the client gets a pre-signed URL from our service and uploads it directly. This bypasses our server. So we have to do some of the chunking ourselves. Okay, I guess I didn't know we had to implement the chunking ourselves. I was just like thinking we were gonna that's abstracted using S3 SDKs or something. And probably it is. No way that they'll make us do that ourselves. That seems like a very common use case. What could be our retrial fail? Our retry and fail strategy. I think pretty much. Let me see. Well, uploading is kind of done asynchronously. I think uploads are gonna take a while to do, and by chunking things and using S and uploading directly to S3, where we're allowed to resume uploads and we're doing very small chunks. It's not like they're gonna. I think the bad user experience is if we're like 90% download uploading a big file and it just crashed, right? And then they had to do it again. So I think no matter what, it's gonna take a while to send the data. So the best retrial and fail strategy is have it so that they can continue uploading from where they're at on failures, and yeah, just retry the chunks that the server didn't receive. So I think that's kind of our retry and fail strategy. How does that sound? Yeah, yeah, you're right. Why? What were you thinking? What were you thinking for the retry strategy? I think actually we just got into this right here. So we're gonna uploading large files can be challenging due to network interruptions. So our system allows or is able to handle this because what we're going to do is break our files into chunks, and S3 also allows us to resume uploads of those chunks if they're partially uploaded. But essentially, the way we're gonna have it is that we're gonna break things into chunks, and if things fail, we only need to retry the chunks that didn't get to the server, and we don't need to start over from scratch. So the client, it's kind of yeah, like the client kind of breaks it up into chunks and then could independently send these chunks to the server. Kind of similar to pretty much how packets are sent over the internet. We break it into chunks and send them over, and only have to retry the ones that failed. And then on the pretty much, yeah, once all the chunks are there, we as chunks are uploaded, we can update a progress bar, and they never have to start from scratch. They just need to re-upload chunks that failed. So yeah, that's kind of our strategy there. Would it make more sense to save the chunk status in the DB? Farzan, I don't think we need to store it in the DB because chunk status is purely a client side thing, right? We only really need to store things in a DB that need to be shared across clients. But yeah, the chunk status is very specific to the client. So also we don't want to introduce any latency. For example, if for every chunk we need to store in our database something, that adds extra time that we don't really need. So if we can get away with it, I don't think we need to do that. Add chunk. What do you mean the client crashes? I see, I see. But I think, but like the chunks are very deterministic, right? You take a file, if you're gonna break the chunk into 50 parts, it's gonna break into the same 50 parts. So I think that's also what it's talking about right here. So when we break it into chunks, we can have hashes for each of the chunks, so we know what chunks we need to send. Imagine the client breaks or the client crashes. Um, Essentially, we could just like chunk it up the same exact way, like 10 to whatever, like 10 megabytes each, and it should generate the same exact chunks with the same exact hashes, and we could just continue uploading ones that we don't have. But I guess yeah. Yeah, Farzan, you're actually right. You're actually right here. I think we need to use the approach, the like we need to have a hybrid approach here. So yeah, we can do it asynchronously. Yeah, exactly. Y'all are right. We're pretty much gonna chunk it up, and then we're gonna send them. We're gonna store these hashes in the database, and pretty much if the client crashes, we can re-chunk it up the same way and figure out and just resend them. Okay, let me. We only need to upload. Nice. Yeah, I think we need to store in the database. So here's how. So the client splits the files into chunks. It'll calculate an MD5 hash for each chunk. These hashes are sent to our file service along with the chunk size and order. Then we have to store all of these hashes in our database with the upload ID. That way, if it's interrupted, we can recalculate the hashes for the local chunks and send them with the resume request. That makes sense. Yeah. Honestly, for meta interviews that are only 45 minutes, you don't really have to get that deep into this. You kind of, I mean, the deep dive is a deep dive. So, but what I seen is, yeah, this is if you want to go super in depth. I think for like senior and staff, you'll probably need to go that in depth. but then they'll make you rush through because in a 45-minute interview, right? They're probably gonna make you rush through the core entities and then dive deep into like how we're gonna handle that. Bro, look at this stuff. Okay, how can we reduce the bandwidth usage and make the sync process faster? Yeah, this is like super in depth. So how can we reduce the bandwidth usage and make the sync process faster than downloading full files each time they change? Okay, I think Farzan already kind of talked about this. Is we only yeah we kind of we kind of just need to figure out like the diff. Yeah, figure out like the diffs between what's on the server and what we have client side and only download those chunks. And honestly, that's in a interview, that's kind of what I would say, and then see if they want to pull deeper into that. So pretty much, since we're already doing chunking, we can update our system to pretty much look only like find a diff of chunks that we need in order to build the latest version on our client, and then only pull for chunks that have changed or chunks that essentially have got deleted. But yeah, we're essentially if a chunk hasn't changed and it's still in the database, we don't need to actually fetch that chunk, and we just need to be smart of what data that we're uploading, and we essentially only need to download the difference of what happened or what's in the server and what's on our client. That's like my high level explanation. Let's see if they give me a fail for that. So what did he do? Okay, so okay, this is actually smart. So what they'll do on the client side, they'll break down the files into chunks, and then they compare when syncing. They compare these hashes to identify which parts of the file have changed. So it's we're just adding client side logic and making the client really smart. And pretty much when syncing, we compare these hashes to identify which parts of the files have changed and only transfer the modified chunks. This way we're not downloading entire files. We could use selective compression. Yeah, like I don't even know if you need to get deep into that. But I think in general what we were saying of only uploading chunks that we need is kind of the direction we need to go. How can we minimize the time required to detect that a remote file has changed while not overloading the system? So one way we can minimize the time to detect file changes is when clients spin up, they'll connect to our file sync server and essentially set up a SSE, a server side event connection, so that the file server could send changes to files directly to the client. Wait, actually, let me rethink that, because that will allow them to see changes right away. And then before I give this response, let's just draw it out and then figure out how that's gonna work. Because pretend we have another client, right? The client is also going to be able to upload files to S3. The client, we have a separate client that's going to upload files to S3, and it's going to notify the file sync server, and then we need to or what essentially, okay, what we can do is, because we have upload server here. Yeah, but we could scale the file sync service. We could scale this horizontally, but what we can do is, when files are uploaded, we can have a queue for each client. We can have a topic in Kafka for all user, like for each user, right? So when we upload, the file sync servers we can scale that horizontally. But what it'll do is when clients connect to the file sync server, it's that file sync server is gonna have an SSC connection to a client, and also subscribe to the Kafka topic for that user. Now, essentially, when clients make pretty much upload files or make changes, what we're going to do is put in the Kafka topic that a change has happened. The subscriber, which is the file sync servers, will automatically will like get pushed these changes, and via SSC it will notify the clients that something has changed, and then they'll go and pull that event, basically. So that's kind of how we'll do that. Um, yeah. How does that sound? Does that make sense? Dude, this Dropbox thing actually is deep. Yeah, but I think it can publish messages for you to consume. That makes sense, but I think we want to separate out that logic. We don't want our database, or I think we need to separate concerns here. But I think there's no right answer here. I think your approach works as well. But I think with this approach, we can separate concerns, and we can sort of scale horizontally our file sync server, and also like our notification service. With Postgres, would CDC achieve the same thing right here? This is kind of Farzan. This is kind of CDC. We're using the queue to capture changes, right? Um, Pretty much when things change, we push it to this queue, and then we want to use Kafka because we want to push to all the subscribers right away that there's a change, and then pretty much all of these servers will probably have a list of like user ID, and then like the connection, like a bunch of connections, connection one. So do you keep the changes on the queue? Do you keep changes on the queue forever? What happens in your example if you have two clients and one is just off for a year while one keeps updating? Alpha code. What's gonna happen is it's gonna this if a client is not gonna be logged on, then it won't have a connection to a file sync service. Basically, when they turn off the client, this connection is gonna get dropped, right? Because it's a HTTP protocol at the end of the day. The asset server side event. So when clients log in, they go to the app server. The app server redirects them to a file sync server, which they'll make a direct server side event connection with the file sync server, and they're gonna get notified as changes happen. And then alpha code, like when something logs in after the year, what it's gonna do, like pretend this one logs in a year after. What it's gonna do is it's gonna first call our sync API to sync what's on that client. Yeah, we have, like we talked about this earlier, but when clients spin up for the first time, they're gonna always want to sync with what's on the server, right? And then once they start up, then they're only gonna sync periodically. But as clients start up, they're automatically gonna have to sync. It's like when you spin up your GitHub repo, you're automatically gonna have to do git pull. Why do we need separate queue for each user? So we can subscribe, because pretend we scale this horizontally, right? Different different file servers are gonna handle different users. So then they only need to subscribe to the users that they need. When we need to scale this horizontally, if we subscribe to one big queue, then all of them are like pretty much all of them are gonna receive updates, even though like pretend this guy is only connected to this file sync server, this client too. You know what I mean? This is just more fine grained, and yeah, we could. Does that make sense? We want to be able to scale this horizontally as well, and scale our queues horizontally. But let's see. Let's talk about let's. Yeah, honestly, well, like the scale here. Yeah, they like each server is only gonna handle a subset of users, but it's not that expensive to make a topic per user. You'll see this same edge case. Yo, right Q, it's good. You'll see this same exact strategy when it comes to like designing a messenger service, and all those other ones. They'll kind of break it up by queue. Yo, right Q, what's good? Um, it's yeah, SSC specifically. SSC specifically. We're just doing system design. We design Dropbox. Okay, let me see. So, how can we minimize the time required to detect that a remote file has changed? We're gonna do this pretty much by using server sent events. So clients will connect to a file sync service, and essentially what that the different servers there are gonna or are gonna maintain SSC connection to the different clients so that it can update the clients when changes happen, and the client doesn't have to poll. So that's essentially how clients are going to receive near real-time updates, and how they're going to know when to update a client is going to be through pub sub. So basically, as clients make changes to a specific file, it's going to the uploading server is going to handle is gonna receive is gonna know when things update, because we're gonna be hitting that put command to update a file. As soon as they hit that put command, we're gonna store we're gonna push to a queue or a Kafka topic specifically for that user, and pretty much yeah, the different file sync services will subscribe to those Kafka topics based on what users they have SSC connections to. And as changes happen, they'll be notified right away. And through service and events, they can notify the client right away. So we're gonna change the model here to more of a push model instead of a pull model. We're gonna leverage SSC, and yeah, we're gonna pretty much create a Kafka topic for each users, so that file sync service could subscribe to those topics and then figure out when changes happen, and pretty much faster, or be notified when things change, and then broadcast that to all the different clients. Damn, that was a mouthful. Let's see what the answer is. Oh, they just do conditional polling. I think we overcomplicated it. They just did straight polling. But I think there's multiple answers to this solution. Yeah, I don't know. Let's read what they said again. It's not really exponential back off, but it's just more like smart polling. I see, I see. Yeah, we just make the client side smarter when it comes to polling. Like, why would we need to pull files that aren't really used? Yeah, I don't know. There's like multiple solutions, bro. Farzan, what's your solution? Yeah, I think mine is probably is a little bit complicated too. Maybe it's not what's needed there. I think both will work in a if we do a system design interview, we'd all still pass there. Nice. Do Dropbox. That's an easy question, but that actually got pretty deep. What else are we doing? What should we do next? Let's design Tinder. Yeah, I paid like $30 for a whole year. It's actually a good deal. Take a quick break. Maybe be back in 5. Take a quick break, and then we'll design Tinder. Let's just say 10 minutes. Back in 10. Yeah. Yo, thanks for even hopping on and watching. This is super, like y'all taught me a lot. This is way funner than doing it by myself. Maybe I'll do this again tomorrow. But we're gonna go through more questions today too. We just did design Dropbox, and I'm gonna upload all of these too. Yeah, I already done Uber. Let's go. Design hotel reservation system is really interesting. Maybe I'll do that. I'll do Tinder first, and I'll do. Okay, I'll be right back. I'll be right back. Yo, yo, yo. Let's design Tinder. An interesting part of this problem was also syncing or um, and how do we handle how do we handle how do we upload large files and retry if oh, how do we it's it's we chunk data. Um, what else? What else? Nice. Checking audio. um, just create a diff. Should have forgot the chat. Your chat. What's everyone saying? Yeah. Let me just like write down for URL shortener. I'm just trying. I need to write down. Okay, I'll figure that after. Okay, let's design. Let's design Tinder. Design a dating app with swipe functionality similar to Tinder. Tinder is a dating app that helps people connect by allowing users to swipe right to like or left to bypass on profiles. It uses location data and user specified filters to suggest potential matches nearby. The functional requirements are users can create a profile with preferences and specify a maximum distance. Users can view a stack of potential matches in line with their preferences. Users can swipe left or right on profiles. Yes or no. 20 million daily active users. Let's just like pretty much let's just draw out the UI quickly. We have all the different people. I mean, you pretty much look at a photo of a person, and then you there could be like multiple photos, right? And you can say yes or no. I think the interesting part, yeah. Let's see. Might be it's good. This one's gonna be good. So this is what the client sees. Non-functional requirements, probably availability over consistency when using the app. Like when they open the app, they need to be able to receive people and be able to swipe on those people. We should have consistency when it comes to matching specifically though. We don't want to match twice. I mean, yeah, we don't want to keep matching with the same people. Wait, see. Okay, availability over consistency when using the app. Support for concurrent users. Yeah, we definitely need to handle scale, but do we need to be notifying them in real time? Scale to support. Are they actually going to be concurrent? I don't think they're going to be concurrent. I think they're just going to be like dumb web clients that kind of will either request when they want to see the next 10 people that they can swipe on. Scale to support. It's not going to be like they're going to all be connected with a WebSocket or something. Consistency for matching specifically. Availability over consistency. And low latency for finding for consistency in the way if I reject someone or left right. I think consistency as in if we match someone, they're gonna know that we matched them. Kind of like we don't want some people like you don't want one person to think they matched but the other person doesn't know about it. Essentially, both users have to have swiped, and both users should be notified. Low latency, sub 300 milliseconds to generate feed for people to swipe on, and then feed should be infinite. Yeah, I guess. Yeah. I think this is a good set of things we have here. We should make it available so that when they use the app, they always have it. We have consistency when it comes for matching. So both users have to have swiped and both users should be notified. We should be able to generate a feed of people to swipe on um, with low latency. And the feed should technically be infinite. And yeah, data privacy and be able to scale. Nice. Okay, strong consistency when swiping. If user says yes on a user who swiped yes on them, they should get a match notification. Scale to lots of users, concurrent users, 20 million daily active. Load the potential matches, stack with low latency. Okay, we kind of hit everything there. Nice. I kind of arbitrarily chose 300 milliseconds, but I guess it checked out. Core entities. Okay, to figure out the core entities, we need to look at our functional requirements and kind of dig that out. So I just took a screenshot. So of course we're gonna have users, and users is gonna be we'll say profiles, where you kind of make your profile with all of your different interests. Then there will be different profiles. That'll include then there will be then there's going to be a matches. And there we're gonna be and for each person we're gonna want to store if we shown them to the specific, we're gonna need to store if we shown them to the date to that specific person. So we could probably store that all in matches. Stores like in our what can we say if two people are shown both to each other? We can create one table for that, I think. We can say that it's like couples or something, or possible match or something. I don't know. Let's just say matches and pretend matches also contain if one person said yes, or pretty much will contain if one person said yes or not. I'm trying to see how we would model this. Do we need matches, or I think okay, since let's just like say there's gonna be matches, and then we're gonna show like this is hard to name potential matches. Oh yeah, interaction or something like that. Like we're gonna show, and then if they match, yeah. So we keep track with two profiles involved. To know interactions, and yeah, we'll have a separate one for matches. Bro, thanks. What else do we need? Profile. Yeah, you're right. You're right. Nice. Yeah, they kind of have this like a swipe. Nice. They have interaction, and maybe the matches will contain the different interactions. So if two interactions happen, then it's a match. Okay. We need to keep track of these as well. So what are the different API endpoints we're going to have? So we're going to have, let me do this. So let's just like copy our functional requirements down here. Oh, it doesn't even let us. But what we're going to do is we're going to have our different functional requirements right here. I'm just going to shrink that. Just so we can figure out our API routes. Users can create a profile with preferences and specify a maximum distance. So we'll just do post. I mean, they'll be able to post when they're creating a profile. I think let's assume they already have the profile when they create it, when they do like a create account. So we pretty much have put profiles. Say description allows us to, like, we have a put request here that allows us to update profile. Header is the auth. Backend will decide which row in DB to update based on auth token. And then in the body, we could specify the different things like, yeah, we can change the age, range, etc. Age, range, other metadata. And then this should return us back our profile. So that allows us to create and then we can get feed just the get a list of profiles. Do we need to support pagination here? Auth token. We'll still have an auth token so we can pick for, like, get the right ones so we could figure out who to match with. Or do we need to do paginations? Probably. I mean, gets a list of 10 profiles. Yeah, we'll definitely need cursor based pagination, and this will return us a list of profiles. Do you mean put user ID here? Kubran? Do you think that there will be any security concerns if we allow the client to specify their user ID? usually the clients shouldn't. Yeah, like essentially clients should authenticate, and once they authenticate on the server, we should maintain a session, and in the client we'll just have a session ID, and essentially we'll pass in the session ID to the backend, and then the backend will figure out who the user is based on the session ID. So you can't fake that you're a specific user unless you hijack their session ID. But that's a lot more. That's a lot harder to jack, like a session ID. A session ID is harder to jack than a user ID, because pretend I start guessing people's user IDs, and then I just start figuring out. Yeah, user ID should be hidden on the session, and it should be hidden on server side. So pretty much when I say auth, that's kind of handling all that. Markel, what's good, man? I know a Jacob. I know a Jacob for sure. I have a cousin named Jacob. I don't know if it's the same one. I don't know his middle name either. Oh, yeah, I know that too. Then users can post. Let's say interaction. Um, so we say yes or no. Maybe we'll just do a body, and we'll say profile ID of the person. How does it change your design? That's going to be later in the deep dive. So not users can swipe left or right to express yes or no to other users, and users get a match notification if they mutually swipe on each other. Okay, I think this hits all of our requirements here. Damn, what did I forget? Oh, shoot. So get. Okay, we didn't pass in query parameters. Yeah, we just didn't pass in query parameters. Oh yeah, this needs to be by lat long. Do some deal hashing stuff. What else? And we'll figure out the preferences in the back end. But oh shit. Okay, we're getting to high level design. How will users be able to create a profile and set their preferences? So we're probably gonna have a client here. Obviously, these are usually phones. we're gonna have an API gateway because we're probably gonna want to separate our service for updating or for updating preferences from the service that like our reads and writes should be separated because our read service is gonna handle a lot. We could probably, to simplify it, we'll just have a simple app server. And then we have our simple database. So Markel, like what time is it for you? I don't know, man. I just like to do this stuff. 3 p.m.? I don't know. Usually from 9, I drink a lot of coffee. That's one thing I do. So how will users be able to create a profile and set their preferences? So users will be able to create a profile by pretty much using the post request to create their profile. Like there's probably some sign up form where they'll be able to sign up, or they can sign up using Google or something, and then we could do OAuth. But essentially, let's just assume that profiles are already created. In order to update their preferences, they're going to make post requests, and the API gateway is gonna route that post request to our app server. The post request is going to grab the body of the app server is gonna grab the body of the post request and parse out the details, such as the preferences they want to update. It will generate the query for the insert query to the database, or for the database, and insert it to the database, and then return to the client 200 if it's successful, 400 if it was malformed, 500 if there's a server error, like all the general stuff. But that's kind of the data flow. What happened? How did I get... Where's the feedback session? Nice. How will users be able to get a stack of recommended matches based on their preferences? Okay, this is a bit harder. One sec. Let me set up my dinner real quick while y'all think about this. How will users be able to get a stack of like, this is a very interesting conversation. I think in the interview we'd probably spend a bit more time on this. I'm gonna eat some Trader Joe's. Tonight, where are you based? Eating healthy. Sick. Do you work right now? Mike, it's good. Yeah, internships count, bro. Yo, what are y'all thinking about? Everyone drop in the thing how they think they're gonna figure out the the matches. Oh, Pabron. Seems like he knows what he's talking about. Pabron, like, figuring them out on the fly is possible, but it introduces a lot of latency, right? It's still, I know what you're saying. I know exactly what you mean. There's two ways. We can pull it and we can generate, we can figure out on the fly, or we can pre-generate it. What do others think? But yeah, I think your approach there makes sense. I was thinking the same thing. But Baron, any, like, can you be more specific on how you're gonna generate this cache? Like where is this cache gonna exist? Who's gonna write to this cache? When is that cache gonna get updated? Can you be more specific? That takes the user. So what is it gonna do? What do you mean it's gonna take the user database? Could you write it out? Be more specific there. Okay. I'm gonna go with your approach here, and we're gonna have a Redis cache. Right? So we're gonna have a Redis cache, and in our Redis cache, we're going to have a queue for all the users, for every by user ID. So we're gonna have a queue for each user ID in our Redis cache, and essentially when the client wants to grab the next, let's say they want to grab the next 10, they're gonna just grab it from this Redis cache, right? Oh, I skipped ahead. So when they want to grab it, they're gonna grab it from this Redis cache. Let's see. Wait, let me just reply to someone. right? Let's say, what, like I haven't really used Tinder, but I've seen how it works for people, and pretty much there's a predefined number of swipes that they get a day. Right? So they get a predefined number of swipes a day. So I think what we need to figure out here is what we need to figure out here is how we're going to populate this cache. And what we could do is asynchronously, we could have like a async job, like maybe Lambda functions or something. Kind of like cron, whose job is to populate the swipes for a specific user for a day, right? This is happening asynchronously. So pretty much the Lambda function connects to the database. It could be talking to some ML service. Like there could be some ML service, right? But what the Lambda function is going to do is going to talk to both the user, our regular database, and our ranking service, and essentially generate a list, basically generate the swipes for a user for a day. And while it's generating that, it's going to be populating this Redis cache asynchronously. This is kind of annoying. Right? So we have the Lambda functions that populates the caches async, and it can use like a ML ranking service. It'll see people that are nearby. Yeah, it will basically query the database to find people nearby, maybe through geohashing or something, and then also query if you already matched with them and stuff. And also make sure you didn't match with them. After that, it's gonna pass it to our ML service that's going to rank them, and then from there, we'll populate this Redis cache asynchronously, right? And then store the interactions in the DB, so that so now we're kind of keeping it in now, but we have a consistency problem, right? So maybe we could probably get rid of this Redis cache and we could just store it straight in the DB and have interactions and a cursor to when that interaction was generated. So we don't have a consistency issue, or we don't need to deal with consistency between our DB and Redis. But we'll talk about that later. Purbaran, how does that sound? I think consistency here is important. And sorry if I'm completely saying your name wrong. And where are you based? Oh, nice. Thanks for connecting, bro. Legend. 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 Thanks for tuning in, bro. Okay, how we used to be able to get us. Okay, so what we're gonna do is so to get the recommended matches, there's two approaches here. We can either when a client is finished with looking through their potential swipes, and they either swipe no or yes on all the ones that we've already sent to the client, they can make a GET request to our service, and we can eventually figure out what are the next matches or what are the next set of matches that or interactions that we want to show this client. But that can be really slow. It can be have a lot of latency because we're gonna have to do a bunch of queries on the fly. Maybe talk to the ML service on the fly and figure out the best ranking for people we should show them. So what we can do is actually just pre-generate all of the interactions that we want this user to have, and we could pre-generate it asynchronously using like a Lambda cron job that populates a Redis cache, and the Redis cache will have keys for every user. So pretty much when a client asks for the next set of interactions, it will ask the server, and then it will just pretty much pull from the queue, first in, first out. And yeah, we'll have the Lambda's functions actually pushing onto that queue. The Lambda function will have access to the database, so it'll know who you interacted with already. It'll know your preferences, and it'll be able to like perform geohashing to filter down people who are close by you. Then it'll be able to pass all the profiles near you to a ranking service and figure out who should be the next like 10 swipes or something like that. Or yeah, the ML service will essentially rank people, and yeah, basically it'll populate that Redis cache. Got you, bro. Are you on the Discord? Bro, go on my profile. I can't send the link right now, but go on my profile on YouTube, and you're gonna see the Discord link if you go on my profile right away. Because it won't let me even send that. Or every time I go on Discord while I'm streaming, it like doesn't let me pass the link. So this is very efficient and will improve in our deep dives. So they're kind of just saying like a naive approach as well, which is just like on the fly per run. But honestly, we shouldn't save it for the deep dive, because what if the interviewer just thinks we're overlooking something, right? I think they're just doing that, but that's not really. I think in terms of interview, you should just front load that before they start thinking you don't know what you're talking about. Yeah, this is like a basic playbook answer. So users, so pretty much the client side will have a list of interactions. Essentially, we'll have a list of profiles that they're gonna say yes or no to. For every profile that they say yes or no to, we have access to the profile ID client side, and we'll send a post request saying we're basically saying yes or no for that specific profile, right? Pretty much when they send the post request, the app server gets that post request, and then we'll probably first check a couple things. Yo, Caesar, what's up? We're designing Tinder. Yo, did you just get home? Hell yeah. Oh yeah, Caesar's here, so he knows how Tinder works, so we're gonna talk about this. I'm swiping right. Pause. So basically, this is what we're doing. We have a Tinder. When we have a bunch of profiles, you'll say yes or no to each one. Let's go back to our non-functional requirements. So our functional requirements are pretty much users should be able to create a profile, specifying their age and their interests. They're essentially like to say the different things, like the things about themselves, like if they're 6'2", like pretty much all the things related to their profile. So they should be able to create a profile, and then after they create their profile, they should be able to get a news feed, or basically a feed of people who are nearby and might be a match for them, right? So then they're gonna swipe left or right on each of these specific people. Shabbat, nah, I can't. I don't want to make money off my thing. I don't want to monetize it yet. It's against my visa, basically. So, essentially, yeah. Once on the client side, we're going to be able to say yes or no on specific users, and if both of them say yes, we should notify them both that there's a match, right? So that's kind of the functional requirements. I'm pretty sure y'all have used Tinder before or some sort of dating app, but our system needs to scale to 20 million active users. Shabaj, yeah, it sucks, bro. It's all good. And okay, what I also mentioned is we're gonna prioritize availability over consistency for the app. Meaning, I mean, actually, that part doesn't really matter. But essentially, when we use the app, we just need to. Essentially, when they use the app, they should be able to see profiles and stuff. It should be highly, like the uptime of our service should be up, or like 99.9999999. But then also we need consistency when it comes to matching. So if two people match, we need to make sure that's highly consistent, as in both users should have swiped in order for the match to have happened, and both users should be notified, right? So that's another non-functional requirement. Another non-functional requirement is that when someone loads up Tinder, it should generate them a feed of people to swipe on very, very fast. It shouldn't be slow. It should be under 300 milliseconds. Um, Feed should be infinite. I mean, that's not really the case actually. Like usually people have number of swipes per day, right? So feed should be infinite. Probably not. Feed should be finite, unless you have premium, right? And then maybe we can buy more swipes or something. Um, Data privacy, we don't need to. We need, obviously that's the case with most apps. Scale to support 20 million. So that's kind of our non-functional requirements. Our core entities, and Alpha, welcome back. Our core entities are profiles. So we need to, in our database, we need to have a table for our different profiles where we'll include all the people who created accounts and metadata that they submitted, like their location, their height, their weight, their preferences and stuff like that. I mean, they don't add weight. Um, that would be crazy. But pretty much we'll have a profiles table. Then we'll also store the interactions, because we need to know the different interactions with the different people. We need to know who you said yes and no to, right? And eventually, if two people say yes, so two interactions are yes for like two people, we're gonna generate a row in our matches database. So we have simple API endpoints for updating your profile. So from time to time, if you want to improve your profile, maybe you're not getting the matches that you like, or maybe people are passing up on you too much, you're gonna tune your profile and hopefully get more matches. So you need to hit this put endpoint, which allows you to update the profile. So yeah, you can update your profile, and then we have a get endpoint that essentially what it's gonna do is you're gonna, every time you do a get request to the feed, it's gonna generate you 10 new or it's gonna give you 10 new profiles, and we're going to do some sort of pagination there, maybe cursor based pagination. But essentially, we're just going to return 10 profiles at a time, allow you to swipe through them, allow you to look through and see if you're interested in this person. And then after you're like, maybe when you're at like the 8th or 9th profile, we'll do another get request to get 10 more profiles, so that it seems like you have like an infinite scroll. And basically, when you're on each profile, if you say yes or no, we send a post request for that specific profile ID you said yes or no to, and we're going to store that interaction in database. That's kind of our data model. And this is does that make sense so far for the data model, everyone? Okay. And as Pubaran was saying before, one of the non-functional requirements was under 300 millisecond latency when it comes to generating a list of interactions. So, I mean, there's two ways we can do this. We can do a pull model or a push model. The pull model is when the client pulls for the next set of profiles. I mean, they'll always pull, or basically the two options is generating the interactions on the fly, or pre-generating them. So on the fly would be, pretend I'm a client and I exhausted my swipes, so I make a get request to my database to get the next 10 swipes. Essentially, what we can do is, when they do that get request, we can query the database to figure out who should be the next 10 people we send this user. And pretty much query the database for that. Make sure that this person didn't already match with those people, or that person didn't already say no to those people. And we could do that when the client makes a request, but that latency is going to be high, because imagine we have to query the database, and imagine we have to talk to some ML service to rank the results before we return it to the client. That's definitely going to be over 300 milliseconds. So the approach that we came across with is pre-generating the list of interactions that we want to show a user and storing it in some Redis cache, where the key is like a user, and they're going to have a queue for the interactions we want to show them. And we're going to have an async Lambda function that's going to be populating their queue. So probably periodically, maybe every day, it's going to query the database to see possible interactions that they never had before. It's going to pass those interactions to the ML service to rank them, and it's going to populate the Redis cache with the different interactions. So that's already going to be pre-generated. So now when a client asks for their next set of interactions, we don't have to figure that out and create a database at all. Since we're using Redis, everything is pretty much in memory, and it could just pull from the queue here and send it back to the client. So that will allow us to hit on sub 300 millisecond latency, and allow us to be smarter with how we're generating the interactions, because then we can interact with an ML service that might be slower. So how will the system... Did we already answer this? Okay, so how will the system register and process user swipes? So, let's see. We have to refresh this. Everyone following along so far? So on the client side, after we did the get request to have a list of possible interactions, we're going to the interaction ID is going to have like a profile ID, or the client side is going to have a list of profiles that's shown to them. And when they swipe left or swipe right on a specific person, we're going to send a post request to our app server with the profile ID and yes or no. And essentially what the app server is going to do is it's going to what the app server is going to do is it's going to pretty much see if there is a match here. Basically, what it's going to do is query the database and see if there's an interaction for the other person, and both of you essentially swiped yes. Because if it did, what the app server will do it will automatically do it like a 200 success to the client and tell them that they did a match. And maybe we could have like a notification service where we push notifications to, and it'll eventually, we have a notification service and we have another other client. So what we can do is we can, if we see that two interactions lead to a match, we'll actually insert that into our database, notify the client that there's a match, and then also push to our notification service. And we'll have a notification service, and that's kind of abstracted, whose job is to notify the other, like send a notification to that other person that there's a match. And it could do that using push notifications if they're using like iOS or Android. So yeah, we'll generate the match there. Oh, sorry, I already went over the 2 minutes here. Nice. Would you use the ML on images here for describing profile? I don't know. I don't think this question really needs to, like, we can involve ML wherever we want to, but I don't think this question specifically needs it. Like, even this ML ranking service is a bit like over. When a user swipes, they'll send a post request. The service records a swipe. To detect matches, the swipe service will check if there's a corresponding right swipe from the target. If, yeah, like as we mentioned, if it is, we'll create a new entry in the DB and also create a match. But then we also need to notify that other client, and we'll let the notification service handle that. Okay, I jumped ahead. The other users needs to know a new match as well. So essentially, when the client sends a post request to saying yes, what the app server will do is figure out if that other person that they just said yes on also said yes. If they did, we'll create a match in the database. We'll create a new entry for a match in the database, and then we'll also push to our notification service that this match happened. And the notification service is a bit abstracted to us, but essentially, if we just pass back the profile IDs, it's gonna know like how to send the notification to that user, and it'll probably do that using push notifications, like Firebase for iOS, and just regular Firebase for Android, and whatever iOS uses in order to send push notifications, but we'll have a separate notification service for that. Maybe this notifications service will have like some Kafka queue that we can push to so it doesn't drop requests. And then we have different consumers that kind of consume from the Kafka queue and send out those notifications. Let's see. Yo, we're destroying these system design interviews. Markel, thanks. So there's a notification service. It'll publish a message to the message queue. The notification service consumes these messages and sends push notifications to both matched users. Yep, using Apple notifications or Firebase. Yep, that's exactly kind of what we said. How would you design the system to ensure that swipe actions are processed both consistently and rapidly, so that when a user likes someone who has already liked them, even if see. This is a good question. I feel like that's what the database is for, right? Let's see. Like if we use a SQL data, I could see if we use a SQL database here, it will be strongly consistent. So basically, when we read the database to look for interactions, look to see if the other person said yes, we're gonna see that right away. So I think like we're gonna need strongly consistent reads, because what we don't want to do is pretend somebody did interact with us and like us. What we don't want to do is read a stale replica of the data and think that they didn't say yes to us, and then we don't generate that match, right? We could refresh the cache and add that user in the list. I think Purbaran, like the main thing when we're dealing with a database and a cache is um, now we need to maintain consistency between the database and the cache, and that leads to a lot of synchronization issues and a lot of synchronization stuff that we have to handle in the application layer. So we don't. So if we could avoid figuring that out by just doing strongly consistent reads on the database, I think that's going to be the better approach. Let me know if that makes sense. Which latency are you worried about? Well, this is gonna be like a microservice architecture where we'll have a match service, and then we'll have our feed service. So for figuring out the feed, um, we could just talk to this service directly. So that system is kind of independent of what we have here. And for matching, we could just make sure that matching only handles logic related to matching, and we'll just need strongly consistent reads on the database here. So I'm just gonna say that. How would so pretty much to design our system to ensure that actions are processed, essentially we're gonna need to worry about is our database reads being strongly consistent or not, because like I mentioned before, our match service when somebody says yes or no to someone, our match service is going to do the job of looking into the database to see if that other person also said yes on them. And if they did say yes, we're going to generate an entry into the database saying that there's a match there, right? So we need strong, consistent reads, and we could achieve that using SQL database, or DynamoDB even has strong, consistent reads. But essentially, what we can do is like, because essentially we don't want to read stale data thinking that person said didn't reply yet. When we read the when like the second person says yes, we need to read the most recent copy of the database across in a consistent manner and be able to generate the match. So yeah, pretty much the match service is going to handle that. We're going to do strongly consistent reads, and if there's two interactions that said yes, we're going to generate a match and then send it off to our notification service. Damn, that was a mouthful. Damn, they didn't like it. What? They're using Redis. I see. Yeah, they use Redis for it as well. Afzal, I got you, man. I'll do that in the morning. I think that these. Afzal, how you been though? Yeah, okay, they use Redis. In memory. To ensure both consistent. We'll store each user's right swipes in a Redis set using the user ID as the key. We'll use Redis atomic commands to add the target's user ID to the set and immediately check if the target user has already swiped on the right on the current user. Shabazz is good. Yeah, you could use it for everything. Okay, yeah, we pretty much just like offload it to Redis. I guess like since it's in memory, it's gonna be a lot faster. Whatever. Take an L there. Bro, we talked about this already. What is it talking about? Okay. Perberon, how can we improve this though? Do you think there's a better way to do this? Before I... how could we generate this news feed in a better way than a Lambda function? So you might want to add the right swipe part. let's see. I see. So how can we generate this? So we have our feed service. Our feed service. What we can do here is instead of a lambda or something, what we're gonna do is we can tell like the feed service will have a queue, a Kafka queue that it writes to. So this could be more event driven. So essentially what's going to happen is as somebody asks for a feed, this adds a bit of latency here, but essentially when they create a profile, we'll generate them a list of their feed, right? And essentially when pretty much what's going to happen is when the feed service sees that somebody's queue is getting low, it's going to push a job, basically push a job that will tell like a worker to generate like the next batch. So that's more, it's event driven. Workers. Bro, so it's gonna be more event driven. So in order to have low latency feed generation, what we're gonna do is pre-generate the feed. So we're gonna have a Redis cache that maps user IDs to a list or a queue of all of the different interactions that we want to show them. It's in a first in, first out manner. So we're gonna have a separate job that populates this Redis queue, and that separate job can happen based on specific events. Specific events could be like the client just signed up, or we could push events such as the users the user has like is running out of interactions, or maybe the user paid for more interactions. So essentially, based on different events, we're gonna push to a queue, a Kafka queue, and there's workers in charge for generating feeds, and they're gonna get events. Basically, the events will just tell them that we need to generate a news feed or a next set of interactions for a user. And yeah, it will talk to the ML service for ranking and stuff eventually, or essentially, and yeah, look in the database to see which interactions are actually valid and who they passed to. Make sure we don't give them people they already matched on. But yeah, kind of we abstract that away. We just have workers that will populate this Redis cache, and these workers will receive events, and there's going to be different events, like somebody signing up for the first time, someone paying for more swipes, someone's swipes are getting low, maybe it's a new day and it's their first time logging in. That's kind of how we'll push things to people's Redis cache. But what, yeah, even when new people sign in and stuff, I don't even know. Okay, they're using a hybrid approach. When they first join, so we have a cache, and then while they're swiping, we'll deliver like fresh, relevant ones. Interesting, interesting. Showing users. How can the system avoid showing user profiles that users have previously swiped on? So we can basically our database is going to be storing all the different interactions, and what we could do is we can index those interactions by profile ID, so we can easily see um, we can easily we can have an efficient query to find all of the basically when we want to show a list of the next list of interactions, we can easily query the database to see who, if any of these profiles we didn't interact with. And also, yeah, basically when we're looking for profiles to send. Actually, let me think about this a little. What do y'all think? What do y'all think? This one's a little bit more. And I'm probably out after this. What do y'all think? I'll load interactive user ID. What does that mean? Oh, I see. Like load it into memory? So you can quickly see. What about just good indexing? But yeah, it's going to be a lot of load. Yeah. You're right. You're right, bro. You're right. Again, how you always right, man. How can the system avoid showing user profiles? So yeah, what we're gonna do is, as we mentioned before, what's gonna be happening is we have our Redis cache that's gonna be storing a lot of our interactions, and yeah, essentially, we're gonna we're gonna know the interactions that are happening, and we're gonna have them in memory, so that when we're trying to generate the news feed or the feed for that specific person, we could easily quickly see if any of the interactions that are in the list we want to show them are is this still good? Yeah. I'll get to that. I'll do that as soon as I finish this. Do you want to hop on the voice chat on that? Let me restart this. I'd rather do it on voice chat, bro. Yeah. So essentially, what we're gonna do, I mean, there's two solutions here, right? It's either we index our interactions well, so that there's gonna be a lot of database calls, but we're gonna make sure, like, we're gonna add the proper indexes so the database queries are more efficient. So that's one way if we just want to manage it in the DB. But if we want to reduce the load on the DB and make things faster because it's going to be in memory, we can use Redis. Redis is going to pretty much have our interactions stored in memory, and when we're generating a feed of interactions we want to show somebody, we can look in the Redis cache to make sure that we didn't already show them this interaction. So this is so this is essentially how we do things in memory. We can either use Redis to cache all that and reduce DB load, but if we can't, if the interviewer wants us to, yeah, we can just index the data in our database as well. Alpha, is that what did you? probably gonna get a trash response here. Or like my answers here is trash. Okay, it's all good, bro. So damn, I'll probably maybe do that tomorrow. First, for users who we maintain a server-side cache of their swipes. Nah, bro, I just post one video a day. That's kind of how I grew it. When storing, checking a full list, we'll implement bloom filters. A bloom filter is a space efficient. Okay, we're using bloom filters. Okay, what the? I don't know anything about bloom filters. Okay, I guess we're gonna use bloom filters. Nice. Got through another one. I'm gonna read that solution more deeply a different time, but yo, we got through a lot of these. Okay, what was kind of interesting about that problem? Bloom filters, obviously. Consistency on swipes and not showing a user. Consistency on swipes and not showing a user. You already answered. Here's bloom filters. What else? What else was interesting? Pre-generate. Do we want to pre-generate feed or generate for each post request? For each. Markel, I don't know either. I'm gonna have to look it up. What else was interesting? I'll probably just read an article on it. But yeah, you could probably just prompt GPT. That's probably faster, more efficient. Okay, let's do that resume review. And maybe if I get a second wind, I'll do some lead code questions. Holy shit. How long has this stream been? 3 hours? Consistency on swipes and not showing a user. No, I'll probably clock out today actually. Well, and then I'll just stream again tomorrow. Consistency on swipes and not showing a user. But I'm gonna do the resume review. Consistency and not showing user. You're pre-generating a feed or generate for each post request. What else? What else was interesting? Notifying matches. cereal went bad. I forgot about it. Okay. Yeah, I'll send it. I'll send it in the. I'll send it in the chat. I'm gonna send it in my Discord once I fill it out. We're almost done. We'll do tomorrow. I'm gonna do hotel reservation. So, web crawler is kind of more important. GoPuff, Java, YouTube, payment system. Payment system is not that important. That's kind of abstracted away from us. Like through Stripe or something. Alpha code, you might need to learn payment system for your Stripe interview. Yeah, yo, let's do that tomorrow. I'm cooked. I need to also Markel, I'm trying to get to staff. But honestly, I don't really care. I'm just chilling. I just got promoted, so this like I barely care. Okay. Carlton. Markel, it's all good. I do a lot of coding on the side anyways. Okay. We have education here and then we have experience. This is nice because you have experience. Why don't you just want to go back to Cisco? Damn. I think the format is good. What kind of jobs are you looking for? You're about to graduate? Like, are you trying to work at Fang? Are you trying to work in more network systems? Or are you trying to work at like regular SWE jobs? Because I think yours is very tailored to network engineering. Yeah, you're bolding a lot. I would say you can make it more results oriented. You need to. I'll send you this thing. And I mentioned this literally on all my videos.
Is preferred. Include your contact.
So what I would say is make your thing more results oriented, right? Like, I see these are things you're doing and it sounds really cool, but I think you could add more metrics, right? So a good way to structure the bullets is like accomplish X as measured by Y by doing Z. So like you could move up your results, your accomplishments to like at the start of the bullet points. You could be like, I reduced troubleshooting time by 30% by enhancing our Python based CLI etc. Right? So basically, I know what you accomplished right away, and then I know how you did it right after. So, and then for example, for this one, like yeah, just have more results, make it more results oriented, and maybe bold the results, like the metrics, right? So I think this is really good. You've shown that you did a lot of things. I would just make sure to add metrics and make sure that your accomplishment shows up first, right? So what is the result here? Is they increase server query response time by 15%, right? Like for example, when you just list out this, it sounds cool, but I don't know why you did it, right? I need to know exactly what's the reason you had to do this project. So this one makes sense. You what you want to do is reduce troubleshooting times by 30%. So you did this work, right? So why did you implement an asynchronous HTTP server with namespace switching? Like what result were you trying to drive there? So I'll definitely make yeah, so I would just like when people read your resume, they want to know the impact and the results you drove for the company. So, like, did you reduce troubleshooting time by 30%? Did you help the company launch internationally? Um, did you, like, help them increase their revenue by 30%? Like, we need to know what you done for the company and then also how you did it. So, I think you're kind of saying what you did or how you or like yeah essentially what you did, but there's no metrics here, so I think that's one way we could improve it. So that'd be my feedback there, and just send it again when you fix that for the specific experience, but your format is good. The bolding is like kind of random. I would just try to bold the results that you drove. And for adding metrics, people think that it's hard to add metrics, but you can literally just talk to GPT and get GPT to generate you random metrics, bro. So yeah, I think this is good too. For the project, it's harder to talk about the results, so you kind of have to say what you did for the project. Um, I would say make them like start off with action words as well. Markel, well, they're just gonna ask you how'd you come up with that metric. Well, you can use GPT to come up with the metrics, but or basically you can use GPT to format you the bullet point and then fill it in with the real metric that you drove, right? In the best case scenario, you keep track of all these metrics and you figure it out. I mean, and you have a list of them. But if you don't, then you kind of have to make them up. And pretty much, if they ask you in an interview, they're gonna be like, "How do you generate this metric?" Just say how you would have generated, how you would have um, got that metric. So for example, if they say if you said that you helped improve an API service and made it response time 30% better, and you came up with the number 30%, and you just literally made it up, and they asked about it in an interview, you could be like, okay, our API servers, we use Datadog to track load times, and then pretty much the way I was able to track that it actually reduced 30% is by checking the Datadog and pretty much seeing that it reduced 30%, and we have like a historical graph, and yeah, that's kind of how I was able to track that it reduced 30%. Like you literally just made up the number, but you were able to back it up. If you just say I just said 30% and you literally have no idea about how to monitor that, then they'll know you're making it up. But if you like reverse engineer it, figure out like how you can even figure out that metric, then just say that in the interview. That makes sense. Like all of these, you could figure out. Yeah, all of these you can figure it out. You no, like use numbers wherever you can, and when they ask you in an interview, just say how you got that number. Say you use Datadog to get that number. If you improve the accuracy of a machine learning model, say that they did testing after to see the percentage or like the accuracy of it or something. Like a lot of things that you could actually track. You know what I mean? Like maybe you didn't track it at that time, but as long as you can say how you can track that metric, then they're gonna believe you. I mean, literally for most companies, you're gonna have to. It's hard to measure code refactors though. Yeah, I mean, mostly. Well, what can you say? Yeah, you might not have a metric for it, but okay. First off, if you're gonna talk about a code refactor, you should probably talk about why you did that refactor. What was the result that you driven? Maybe you refactored the code because there was like 10 there was 10 files and they're all duplicated logic. So you can make a metric for that. You can say I reduced 10 duplicated files into one by refactoring the code base and building like a template design pattern in order to reduce code duplication. So the metric is you took 10 duplicated files and turned it into one, improved the pattern that those files were using, and that like helped reduce bugs because now we're not duplicating through 10 different files, right? So I think you need to figure out why you did that refactor and then like quantify like how much did you actually refactor? Did you like take a thing that was like 10 files and turn it into one? You know what I mean? Let me know if that makes sense. Drop a ack on the chat. Yeah, and I would just use more action words here, honestly. Action words like developed, implemented. Yeah, cool. Um, yeah, more results oriented. Push your accomplishments at the start. It should be like we should like your accomplishments should be at the start of every bullet points. So if I read your resume from top to bottom and I decide to only read half of each bullet point, in my head I still know all the things you accomplished. I might not know exactly how you did it, but I'll know all the things you accomplished. Oh, um, refactored our code base to reduce 10 to 1. Yeah. um, like reduce latencies by 30%, improve accuracy on an ML model by 30%. Like all of your accomplishments should be left aligned on the bullet points. So if I just read it from top to bottom, I just start seeing it because not every like most people will just skim each bullet point, maybe even halfway. Honestly, like no one will gonna read this bullet point. As soon as they get over here, they're gonna stop reading the bullet point. I don't know if that's me, but I think that's just human nature. At some point, like they're gonna lose focus halfway through a bullet point, especially if it's long. So yeah, good job on your resume. I really like the format. We could probably improve some of the bolding and some of the like italicization or whatever, like making it do that. No, your resume is good. I like your resume. Your resume probably better formatted than mine. Okay, how's that for advice? Just put a thumbs up, and I'm gonna clock out. if that's good. If you have more questions, just ask it right now. I'll wait for a bit. Got you, bro. Got you, bro. You got any other questions? All right. Just catch me on the next stream. I'll probably be on maybe tomorrow. We'll see how it all goes. Markel, catch you. Alpha, thanks as always. Good luck on your Stripe interview. Okay, yeah, I'm Canadian working in a US job. How's the TN process? TN process is pretty easy. As long as the company wants you, TN process is you just go to the border and get it. It's pretty easy. But yeah, I'll catch you all in the next stream.